A particle oscillates in a straight line. It starts at a point A, then reaches a point B, 10 meters from A. It reverses direction and travels back towards A, but reaches a point C, only 7.5 meters from B. Each leg of the journey is 3/4 of the length of the previous leg. How far does the particle travel in total by the time it comes to rest, and where does it finally stop? So let's put the question down in summary form then and draw a little diagram for it. So here it is here then. It travels 10 meters to B, then it swings back and travels 7.5, 3/4 of that distance back to C, and then another 3/4 of that distance to D, and then another 3/4 of that distance to E. So it's oscillating, and it's going to come up to a rest, in a sense, around this area here on the diagram. So let's have a look at that then, try and work out what the question wants then. How far does a particle travel? Let's have a look at that first then. Distance travelled. The total distance travelled then. So what have we got? We've got 10 plus, that was 10 times 3/4, wasn't it? That next distance, 7.5. So that's a 10. So the next one would be 10 times 3/4. Then the next distance would be this distance at here, times another 3/4, wouldn't it? So it would be 10 times this times 3/4 would be 3/4 squared. And then I hope you can see the pattern emerging. It would be 10 times 3/4 cubed would be the next one, wouldn't it? Times that subsequent term by another 3/4 plus dot dot dot. So that's the total distance travelled. It's an infinite sum, so it's equal to S infinity. Remember the formula is A over 1 minus R. So our first term is 10 over 1 minus the common ratio, which is 3/4. Because that's the common ratio, isn't it? R, we put it in there. 1 minus 3/4 is a quarter, so it's 10 over 1/4. The fraction rule, when it's underneath it, just the 4 swings right up to the top. So it's 4 tenths of 40 over 1, which is 40, so it's 40 meters. So that's the total distance travelled. And the next question it asks is, where does it finally come to rest? So let's have a look at that. It goes forwards 10, doesn't it? Right, so where a rest position, right? Okay, so let's look at this problem. Well, first of all, from A, we're looking at it from the point A, aren't we? So it's going to go forward 10, then it's going to go back 7.5, which is, I better write that as 10 times 3/4. Then it's going to go forwards 10 times, the next term is plus, and then the next term will be minus, because you're going to take that distance away, aren't you? And the next one will be plus. It's going to carry on like that in the same manner, isn't it, to the 4. So let me just run you through that. It went forward 10, then this distance was in reverse, so that's a negative. Then the next distance it went forwards again from A, and then this distance it went back again, and then the next distance it will go forwards. So that's why this needs to be modified when we take into account the distance from A into alternating pluses and minuses as you go forwards and backwards. So what have we got here then? Well, let's extract the positives. So this is equal to 10 plus this one plus this one, and that will just continue in the same manner. Then it's minus these terms here, so it's minus 10 times 3/4, isn't it, that term, minus this one, minus dot dot dot. So these are two separate sequences, aren't they? This first one is an infinite sum, so we can label that part A, and we can label this sum part B. So here, the sum of A, it's an infinite sum. The first term is 10. The sum of an infinite sequence, let me just write it down again, A over 1 minus R. So as far as this sum is concerned, A is 10 over 1 minus the common ratio. So you're timesing 10 by 3/4 squared, and then another 3/4 squared to get this term, aren't you? So the common ratio is 3/4 squared, which is equal to 10 over 1 minus 9/16 when you expand that fraction. And 1 minus 9/16, 16 over 16 minus 9 is 7/16. So we've got, move the 16 up to be with the 10, 160 over 7. So that's the forwards distance A. Now as far as B is concerned, what does B equal? Well, here our first term is minus 10 times this term. That's our first term. I'll put a circle around it. That's the first term. Alright, I'll just do it again. There's our first term. Okay, so let's put that in then. So we've got the first term, minus 10 times 3/4. It doesn't look very user-friendly, but that's what it is. It's just a single object. That's the first term. What do you times that by to get to the next term? You're timesing it by a 3/4 squared, aren't you, to get this from that? So it's 1 minus 3/4 squared, again. So this is 30 over 4 minus 30 over 4 over, this was the same as the fraction here, 7/16. And this goes back to what we did in the previous term, in the previous module. So 16 times 30 comes up the top. And the 4 times, the 4 drops down to be with the 7. There's a minus tag there. 4 goes into 16 4 times. So it's minus 120 over 7. Okay, so it went forward. That's the total distance backwards. It went forwards 160 over 7 and backwards 120 over 7. So dist from A then is equal to the 160 over 7. Take away the 120 over 7, which is 40 over 7, which you can tap in the calculator. 7 5s are 35, so it's 5 and 5 over 7. 5 7s are 35 plus 5 more is 40. So it's 5 and 5/7 meters from A.